Alright, in this video I'm going to show the Veteran Knight concept from the initial 2D drawing to the final model in the editor. So what I'm showing first is the actual concept drawn by the concept artist, and then we'll see the 3D model and whatever changes were made. So I'll show him in Maya first. So there's this is the old version. The texture's not updated, but it's good enough for when I want to show. The lighting's a little bit off, but in Engine I have the updated model. I just didn't want to bother. I loaded this up and it's good enough for this video. And we can show the mesh. Again, the eyes are separate so that I can turn them on and off, and then I can animate them. But that's your mesh. So now I'll show him in the editor. Here he's updated. As you can see, the texture's much brighter, which is what I wanted. So we can get a good look at his proportions. From the back. So pretty much what was changed were the eyes. If I go back to the concept, these are just too wild and woolly. So we decided to go with a, I don't know, more sensible anime style. And it also matches the other Spartan character. And a good thing about the editor is you can add any assets that you wish. And even an artist can do it because it's done with just a little scripting on the side that you just author a text file and point to the meshes that you export from Maya. If you wanted to export this guy, again, I've shown this before, but it brings up a little UI where you can set your settings and it'll export the character, and then you can load them up into the editor. So you don't need the programmer in order to have him in the editor. It's programmer free, which is what I wanted. That way the artist can author their own content and I'm not involved. And one thing I wanted to do is let's show the Spartan character mesh right beside the Veteran Knight. Let's see, right there. Yeah, that's good enough. So as you can see, they match up with the style of character. So it's not like even though he's a different type of character, it's still in the same style, same type of texturing. And another thing I wanted to show, let's go from the back. There's a little error there with the triangle winding. I'll fix that later. It's good enough for the demo. The characters are the same proportion, pretty much. You can see that their arm lengths are the same, so similar height. The reason why I'm doing that is because each one of these characters is going to be skinned to the same skeleton. And the advantage of that is in both memory and, well, money. If they both share the same skeleton, then they can share the same animation sets. And if they share the same animation sets, that means I can have 40 different characters and they'll all share the same number of animations. So there'll be a huge memory savings. And the other savings will be in my pocketbook, since only a single set of animations will have to be authored for the main characters, and they all can share them. And just to prove that, if I select him, let's see, let's give him -90, 286. And then if I put him at the same location, -90, and I think it was 286. see there. There, you can get a pretty good idea. There are some very slight variations, but nothing, nothing crazy. And that way, see, the wrists are at the same location. So essentially, all I'm gonna, well, I'm not gonna do it, but all the modeler will do is he'll put a skeleton in, and each character will be bound to that skeleton. So he'll have to do that. But once the animations are authored, each one of these characters will be able to share the same animation. So the same running animation, the same jump animation, idle animation, whatever animations he authors, all characters can share them. And again, that saves on memory and money. But even down to the same shoe size. And that was all by design because, again, like I said, I want them sharing animation assets. So the proportions are the same for all the characters. I guess I could do the wireframe mesh. I'll show that. Render mode. So there you can see how they pretty much match up, both characters. And if I move them, I guess we'll pick one of these guys. Move them over here. There you can see. Also the same triangle density, or with just enough amount of triangles is spent on the face, but I spend most of the triangle budget on the face because that's what the player is drawn to. So it's a good idea to spend some of the polygon budget on the face. But at the same time, you shouldn't be going, crazy and modeling, nostrils or whatever. It's just good enough to have the face be modeled a little bit more, since that's the center of attention. So if I put that to solid, there, can get an idea of the characters. So that's one good thing. It's good to keep a consistent style between the characters, both in the modeling and the texturing. So you don't want one character looking one way and the other character looking completely different. For example, let's get a Doom character in here. Well, first the scale is off, but as you can see, that's completely off. So you don't want that sort of thing. So I'll undo that. And another thing I've been working on this week was iOS, I guess last year, released something called Metal, which is sort of like OpenGL ES that interfaces with the GPU on the mobile phones, but it's on a much lower layer, so it gives you direct access to the GPU hardware. So it's a lot quicker. There's not as much CPU utilization with your draw calls and setting render states. And so I got that up and running in the engine. So now the engine supports OpenGL ES, DirectX, and Metal. So the cool thing about this, you're seeing this editor running in Windows, but essentially it's running the same engine that it's running on the mobile phone, which is something I'd like to have because I don't want to keep coding things, every time I do an editor, or I just want to code it once and have it run anywhere. So that was a big success since I don't have to support multiple platforms. I just do an interface for DirectX, one for OpenGL ES, and one for Metal. And then on program startup, I select, if I'm on Windows, I'll instantiate the DirectX render system. On mobile, I'll detect which type of phone you have, and then I'll either instantiate the Metal render system or the OpenGL render system. And that's one thing. The Metal render system only works on phones with the A7 chip and up. So it's iPhone 5S and up. So if you have the iPhone 4, I'll I'll be using the OpenGL ES backend, which, you know, it's not the end of the world. The game will run just as well. It's just that the overheads on Metal are much less than OpenGL ES, and it's also a much cleaner interface. I really liked working with Metal. It wasn't as hard to get it up and running. I think, you know, maybe let's see, 1 week off and on for getting it coded, and then I spent another couple of days again just going through all the tutorials, which you can get them on the Apple website. And I think they also have a deferred renderer demo, which I downloaded, and that helped me out. I could see how they set up their Metal API calls, and then I just did a wrapper to my render system interface. And then the engine just works because it's oblivious to whether you're using Metal or DirectX or OpenGL ES. I have an interface that shields the rest of the engine components from whatever rendering API you're using. So once I had that up and running, everything started working. So that's pretty much what I have. I'll just keep showing the concepts as they get completed by the artists, and eventually I'll have enough of these concepts where I can get the animator to start animating them, and then I'll do a full demo showing the animated character on the iPhone running under Metal with shading. So that'll be pretty cool, because then you'll see the finished product on the end platform. So till next time, that's all I have. Thanks and bye.